Hello, this is going to be a video going over the notes for angle proofs, all right? This lesson is going to be very similar to segment proofs, all right? Just kind of doing the same stuff, but with angles. So just like with segment proofs, we're going to start off by doing some Unit 1 review. Again, just like segments, we're going to start by going over the angle addition postulate, right? And the angle addition postulate says that if D is in the interior of ABC, all right, so if this is A, B, C, and D is somewhere in the interior of that, then angle ABD plus angle CBD equals angle ABC. So you have the first part plus the second part equals the whole thing, all right? It's the exact same thing as the segment addition postulate, just with angles, okay? So we're probably going to be using that today. A definition of angle bisector, right? Remember, the angle bisector, that's like the midpoint of angles. So if D is in the interior of ABC, right? So the same situation as above. Ray BD is the bisector of ABC if and only if the measure of angle, actually let's not even say the measure. If and only if angle ABD is congruent to angle CBD, right? So if both sides of this angle are the same, right? If they're both congruent, that we would call BD a bisector, right? It splits the angle in half. Next one, if two angles are vertical to each other, then they are congruent. All right, that's the vertical angle theorem. So if you're going to use vertical angles, you're going to use the vertical angle theorem. We can abbreviate it as VAT. Linear pair postulate, if two angles form a linear pair, then they are supplementary. Supplementary, of course, means they add up to 180. So what does supplementary mean? Angles are supplementary if and only if they add up to 180. Remember, I told you that linear pairs, vertical angles, supplementary angles, they're going to come up a lot. It's because they're going to start coming up a lot in angle proofs, all right? Definition of complementary, they add up to 90. So that's another thing to keep in mind, all right? So we're going to do 3 proofs here, all right? And the first one is very easy. We're going to start off with an easy one, all right? Given, all right, what are we given? We are given that AR, I can't write today, guys. AR is the bisector of angle BAD. All right, so if AR is the bisector, right, what does that mean? Okay, go back up. Remember, bisector means that both sides of the angle are going to be congruent, okay? So we want to mark that in our picture. So that means this angle is congruent to this angle, all right? What are we trying to prove? We're trying to prove that BAR equals RAD. Well, didn't we just draw that in our picture? All right. What is the definition of bisector? The definition of bisector was that this angle equaled that angle. So let's go just write that down, right? That's our second step. The measure of angle BAR equals the measure of angle, how do they say it? RAD. So our first reason that was given to us, and then we finished it by just saying definition of bisector, right? Or I guess we should say definition of angle bisector, because the bisector of a segment is different. All right, so we're done. That was the first proof. All right, so angle proof's not so bad. Next one we're going to look at is going to be a little bit longer, but not too long. So they give us that angle 1 is congruent to angle 5. So again, let's mark that in our picture. All right, angle 1 is congruent to angle 5. We want to prove that angle 4 is congruent to angle 5. So in a problem like this, we know angle 1's congruent to angle 5. We want to prove 4 is congruent to angle 5. Here it would be beneficial to maybe prove that angle 1 is congruent to angle 4. Because if we did that, then we could use the transitive property. All right, and I told you we are going to use the transitive property a lot. So let's look at our picture. What do we know about angles 1 and angle 4? All right, well, we know they're vertical angles. Okay, so we actually can say that angle 1 is congruent to angle 4, and that would be by, I keep forgetting to write given. I'm sorry, guys. That would be by the vertical angle theorem. All right, vertical angle theorem says angle 1 is congruent to angle 4. And now, just like I said, now we can say angle 4 is congruent to angle 5, and that's going to be the transitive property. Okay, we know they're both congruent to angle 1, therefore they must be congruent to each other. You always be thinking about, can I use the transitive property in this situation, or can I use substitution? Remember, those are the two big ones. Number 3, given, all right, given the measure of KAI equals the measure of TOM. So let's go mark that. So TOM, that's this angle over here, that's congruent to the measure of KAI. So I don't know how to mark KAI, but I'm going to mark it like that. All right, those two angles are equal. So let's write down our given. Tom, and that's given. All right, we got to write down our given as our first reason. Now, we're trying to prove that KAR plus RAI equals TOM. Well, what do we know? So again, what does this look like, right? That looks like the angle addition postulate, okay? Think about what is the angle addition postulate, right? The angle addition postulate states that these two smaller angles adds up to the big angle, okay? So we're trying to prove that these two smaller angles, KAR and RAI, add up to TOM, right, over there. So what are we going to do? Well, we're going to show they add up to KAI, and then we know KAI equals TOM, so therefore then we can kind of use substitution, okay? So again, transitive property and substitution coming up again. So let's use the angle addition postulate for this angle on the left, all right? So we've got angle, or let's do this, the measure of angle KAR plus the measure of angle RAI equals the measure of angle KAI. All right, and so now we've got an equation where KAR is being added to RAI to equal KAI, but we know KAI equals TOM, right, TOM, so we can replace KAI in that equation with TOM, all right? That's what we're going to do, and if we do that, then that'll give us the equation that we're trying to prove. So this was the angle, let's just shorten it up. That was the angle addition postulate. And then for our last one, we are going to finish off with what we are trying to prove. That's KAR plus the measure of angle RAI equals the measure of angle TOM. And that would be substitution. And so we are done, all right? We are done. We've proven this problem, and so we've proven all three of our proofs. So this is kind of how you go about angle proofs. Again, I can't tell you, like, here's the one way to solve every problem, all right? Because everyone is different. But you just got to look at what you're given, look at your picture, and then kind of think about what you know. So that's it. We're done with today. If you have any questions, let me know. Other than that, have a great day.